of this system of linear equation, you cannot use either inverse method or the Cramer method because the coefficient matrix, what is delta? Delta is a coefficient matrix. 1, 2, 1, 1 minus 3 minus 1 minus 3, 4, 1. So this one is 0. So we cannot use Cramer or inverse method. And even if we go for the mode, if you go for mode, go for equation, go for ax plus by plus cz equal to d, input this one, you give you a math error. So we should have a new method. Okay. Okay. But please, someone of you take a screenshot from this one and put it in the chat. Okay. So we have to find another method to get rid of this problem when we have the coefficient matrix determinant equal to 0. This method, we call it Gauss elimination method. So this method, we call it Gauss. So we are going to using Gauss elimination method. Solve this, right? So we know we are going to use Gauss. What is Gauss doing? Gauss doing like when we solve two equations simultaneously, right? We just try to get rid of one of the variables and to get the other one, right? So how to use Gauss? You have something called the augmented matrix. Augmented matrix, it means you augment the coefficient matrix with the constant matrix, right? So this augmented matrix is exactly the coefficient and you just make very fat line and you write the constant value which is in the right hand side of the equation, right? Now we would like to keep the main diagonal. What is the main diagonal? This is the main diagonal. And try to make zeros down the main diagonal. And if I am brave enough, I will take and make the 0 above this one. So how to make this one 0? This is the third equation. This is the second equation. This is the first equation, right? If I would like to make this one 0, this one is a coefficient of x1 in this equation, right? Fine. So here, this is a coefficient is 1. So we multiply this one by 2 and subtract it from this one, we will have 0, right? This is what we are going to do here. But instead of working with equation, each equation here is just represented by a line, by row, sorry. Each equation in this one is that this is the first equation. This is the second equation. And this is the third equation. Okay. So how I can do this, they call it row elimination method. I will just multiply by the coefficient just to have the same coefficient. When I subtract, I will have 0, right? So I just keep this one and then make this one 0 and this one 0, right? First, and then I will go to this one. Let's go step by step. This one, to make it 0, there's 2. They are in the first column, so I'm working with the first row. Okay, so what you are going to do, this is 2, but the corresponding one in the first column is 1. So I have to multiply R2, I subtracted by 2 of R1. Okay, what about this one? To make this one 0, this is 1 and this is 1, so it is easy to subtract the third row with the first row. Don't hesitate to do this one simply in the margin. You have R2 minus 2R1. So I'm writing R2 first. What is R2? The second row, 2 minus 3, 4 minus 4. Okay. What is 2R1? 2R1, you have 2, 2 minus 6, 6. So I multiply the first row in 2. Okay. Now I'm going to subtract. Subtract this one, 2 minus 2, 0, and this is what I'm looking for. Minus 3 minus 2, it will be minus 5. 4 minus minus 6, it will be 10, because it will be 4 plus 6. Minus 4 minus 6, it will be minus 10. So the first row stay as it is. The second row, it changed up to this one. So it will be 0, minus 5, 10, minus 10. Let's go for R3 minus R1. R3 is 1 minus 1, 1 minus 1. Subtracted by R1, which is 1, 1 minus 3, 3. When you subtract 1 minus 1, 0. Minus 1 minus 1 will be minus 2. 1 minus minus 3 will be 4. Minus 1 minus 3, it will be minus 4. So I have this one will be 0, minus 2, 4, minus 4. So I have done this one. Okay. Now what's left under the diagonal? This is my main diagonal, and I would like to keep this one. Okay. What's left to make it 0 under the main diagonal? Only this one. This is in the second column, right? So I have to deal with the second row, which is fair enough, because if you go again to row number 1, this 0 will get back into different number, right? So how to make this one 0 when you are using the second row? Yes, the second row is minus 5. How I can make it the same number? Yes, I multiply R3 by what? By 5, and subtract it from the second row after multiplied by 2. Okay. Also, I don't hesitate to make it in the margin, just to guarantee I will have the right solution. I have 5 R3. R3 is 0 minus 5, 10 minus 10. When I multiply it by 5, I will have 0 minus 25, 50 minus 50. Okay. Now minus 2R2. 2R2, when I multiply, okay, I have done a mistake. 5 times R3 is not this one. 5 times R3, this is R3, right? So when I multiply it by 5, I have 0 minus 10. Okay. And 20. And minus 20. Okay. Now I'm going to multiply row number 2 by 5. And I multiply row 3 by 5. I multiply R2 by 2. R2 is 0 minus 5, 10 minus 10. When I multiply it by 2, I have 0 minus 10 and 20 and minus 20. Now if I subtract this one, so what do you have? You have 0, minus 10 minus 10, 0, 20 minus 20, 0, minus 20 minus 20, 0. This is what make the determinant 0 in your inverse or Cramer method, right? Now, what I have now, I have 1, 1, minus 3, 3, and I have 0, minus 5, 10, minus 10, and I will have 0, 0, 0, 0, right? Now, yes, this is, I can write the equation again, right? This is how to write it as equation. If it is like that, I write it in this way. So how I can write this one? Yes, x1 plus x2 minus 3x3 equal to 3 minus 5x2 plus 10x3 equal to minus 10, right? The last one, nothing. I have nothing, right? Okay, that's good. So x3 disappeared because x3 is this disappeared. So you can let x3 equal to any value. I write it t, for example, right? So I have only two equations, 1 and 2. So x3 is a free variable now. So you can let it 1, half, root square 2, whatever. Just to be fair, I will leave it for any constant t or c or whatever. Now I substitute n2. It gives you what? n2, what do you have in 2? I'm just going to write it here. x1 plus x2 minus 3x3 equal to 3. And the other one minus 5x2 10x3 equal to minus 10. This is number 1. This is number 2. x3 disappeared. In equation 3. I don't have equation 3. So it is a free variable. There's a free value. Say x3 equal to t equal to r, whatever. So up to this value, I can substitute into I will have what? Into, yes, minus 5 x2 plus 10. x3 is t equal to minus 10. So I will move this one to the other side. So I have minus 5 x2 equal to, when you move it to the other side, it will be negative sign because it is positive. I need x2, so x2 I will have to divide it by minus 5, so I have minus 10t minus 10 over minus 5. I can take the minus and divide it by 5, so it will be 2t plus 2. So x2 equal to t plus 2. Now how I find x3? I'm just going to substitute in 3. So when you substitute in 3, you have x1 plus x2. What's plus x2? 2t plus 2. Minus 3. What's x2? x3? It is t, equal to 3. Now I move everything to the other side to have x1. I have minus 3 and plus 2, so you have minus 10. Okay, just a minute. Okay. Now you move this one to the other side, so x1 will equal to what? X1 will equal to 3, and this minus 2 when you move this one to the other side. So 3 minus 2 will be 1. And minus t when you move it, it will be t. What happened here? The value of x1 and x2 depends on the free value x3. I have 3 equations. One of them is becoming 0 because the whole row becoming 0. So it means one of the values is free value, right? Okay. Let's have a screenshot for the solution. Okay. Let's go for the second page. Now we know this is the solution in the presentation. Okay, so x2 is becoming in terms of t and x1 is becoming in terms of t because x is 3, I call it t. Now, can we solve this one? Can we solve this one? Guys, we can solve this one by any method. Any method, let's try. Before you go, you have to check the coefficient, the determinant of the coefficient matrix, right? Delta. Okay. Let's have delta for us. If you have your calculator, please help me to find delta.
By inverse method?
We will get delta first. If we have delta is not 0, we go for the inverse or Cramer, right?
Okay, doctor.
2, 4, 1, minus 3, 1, minus 1, 4, 2, 3.
It is 20, doctor.
20. Thank you very much. Very quick. Yes, of course, by the calculator mode, go for matrix. Choose the name of your matrix. I choose mat A, for example. I choose the degree. The degree is 3 by 3. And then you open for me. I write 2 and press equal, minus 3 and press equal, 4 press equal. You will jump to the second row, 4 equal, 1 equal, 2 equal. You jump to the last one, 1 equal, minus 1 equal 3 equal, right? And then you press what? AC. Now you go for shift and what? And 4, right? Why 4? Because in 4 you are able to see the word matrix. Okay. Now, after this one, you would like to find the determinant. Okay. So choose DET. Okay. And you would like to have the math A, determinant for math A. So press again shift and 4 and choose math A. Now you press equal, you will have 20, right? This is how to find the determinant using your calculator. Once 20 is not equal to 0, so I can use what? I can use any method, right? So delta is not 0. We can solve this one, the system of the equation by inverse method or Cramer method, or also by Gauss
Doctor,
eliminations. Yes.
can you solve it by inverse method, please?
Yes, 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 I will do it. Don't worry.
Thank you.
You're most welcome. Let's go for solving this one using the inverse method. The inverse method. What is the formula of solving the inverse method? The inverse method, you have to write your equation as ax equal to b. So x will be a inverse times b. Now, what is A? A is the coefficient matrix. So you have to write in column 1 the coefficient of the first undetermined x1. So 2, 4, and 1. In the second one, you write for the coefficient for the second undetermined x2. So you have minus 3, 1, minus 1. And in the last one, you write the coefficient of the third undetermined x3. You have 4, 2, and 3. This is A. What's B? B is the constant value in the other side. So you have 2, 2, 3. Now, the solution is straightforward. The solution is yes. X, Y, Z equal to A inverse 2, 4, 1 minus 3, 1 minus 1, 4, 2, 3, and I should have inverse here. After I find the inverse, I multiply it by the constant matrix. Okay, do you have your calculator? Okay.
Yes, doctor.
Go for mode. Go for matrix. Go for mat A. And the degree is 3 by 3. Now he will open this one for you. You just type 2 equal, minus 3 equal, 4 equal, 4 again equal, 1 equal, 2 equal, 1 equal, minus 1 equal, 3 equal. You already input this one before, but I tried again, right? Once you input your matrix, you press AC and then shift and 4, Y4, because 4 having the word matrix. Okay. After this one, he give you what? He opened a window like this one. Before you use the determine, in this case, we need the mat A itself, mat A. So choose mat A. Then you have a key here called X minus 1, right? Just press on it and then press equal. What do you have?
Doctor, 1/4.
1/4.
1/4 again.
Row or column?
No, row, doctor.
Okay. And next?
Minus 1/2.
The second row?
Minus 1/2 again.
There you go. Yes.
1/10.
10?
Yeah. 3/5.
Yeah. The last one?
Minus 1/4.
Yes.
Minus 1/20.
Yes.
7/10.
Okay. Now you have A inverse. Okay. This is your answer, right? Just press multiplication now. You didn't input B, right?
Yeah.
You follow this one, and instead of choosing mat A, you choose mat B, right? Catch my point?
Again.
You input instead of input mat A, you will input mat B.
Okay.
For mat B is 3 by 1. It's 3 by 1. Okay.
Okay.
And you input this B, right?
Yes.
Now, once you finish, you just shift and 4 and write mat A and press X minus 1 and don't press equal. Don't press equal. Press multiplication and then
Shift 4 mat B.
shift 4 mat B.
Okay.
Catch it?
Yes, doctor. Thank you.
Doctor,
What do you have?
Can you repeat after X minus 1?
Yes. After X minus 1, don't press equal. Press multiplication. Press what? Multiplication, right? But after you input mat B, after you input what? Mat B. Okay, I will start from scratch. Don't worry. Yes. Now let's input A and B at the same time, right? Again, mode, matrix, go for mat A. Okay. Go for A is 3 by 3. And input this A. 2 minus 3, 4, 4, 1, 2, 1 minus 1, 3. Now I finish. Okay. Press AC. Go for mode again. Matrix. But this time you will choose mat B. Mat B. Mat B is 3 by 1. 3 by 1. Okay, and you input this one 2 2 3. Okay, now press AC. You go for shift and 4, and then you retrieve mat A, so choose mat A and press the key x minus 1, and then press the key multiplication, and then shift and 4 and mat B. Now you press equal. What do you have? You should have 3 by 1 matrix, right?
Doctor, it's showing error for me.
Me also,
You-
doctor. It's coming error.
Error because he deleting A. You just input them in one go, right? Choose mat A and input mat A, and then go for mat B and input mat B, right? Don't press AC twice, right?
Again, doctor.
You input mat A and mat B, and then you press AC, right?
Just once.
Once, yes. If you have it right, you should have this solution. X1 will be minus half. And X2 will be 1, and X3 will be 3 over 2. This is what you have to do to get in your calculator, right? Okay, and this is how to manage using your hand. Fine. Why I'm saying that? This is
Doctor,
a case. This is the cases of solving differential equation. You may have only one unique solution. You may have infinitely many solution, and you may have no solution at all, even if you have 2 variables, or even if you have 3 variables. Okay, if the parallel case, there is no solution. In the having in common infinitely many points, or a line here, or you have typical line here, you have infinitely many solution. And if you have only one intersection point, they call it a unique solution. This is the point. Gauss is very important for this case, infinitely many solution. This case, the second one here, and the middle one here, and the middle one here. But in the other 2 cases, and also this case, but when you have a unique solution, only Kramer inverse working in this case only. Okay, this is the point. Now I'll come back to the calculator and see what's the problem with you.